Hi everyone, Trevor Williams here and welcome to this tutorial on .NET Core and Docker. Now in this tutorial, you're going to learn how to set up Docker, how to set up an ASP.NET Core application, and then how to containerize that ASP.NET Core application and manage that container using Docker. By the end of this tutorial, you should have a fundamental knowledge of how Docker is used, some of the commands that you can use, and how it helps us to deploy and debug our .NET Core applications. Now, this particular tutorial is a subset of a bigger course called Microsoft Azure for .NET developers. And in that course, we not only look at Docker and containers to some extent, but we also take a look at the Azure offerings for those technologies, as well as other Azure technologies that help us to develop efficient and scalable ASP.NET Core applications. So I encourage you, check out the link in the description below for the full course, or you can go to my website, trevorwilliams.com, to see all of my courses and even get discount coupon codes. But for now, go ahead and enjoy this free tutorial. Now, before we jump into Azure containers, let us take a look at containers and what they are and why we use them. So, a container is a standard unit of software that packages up code and all its dependencies. So, the application runs quickly, reliably, and in any environment. And that is, well, I paraphrased what is written, but that is the explanation coming from docker.com. Now, why do we need containers? And this is a kind of buzzword you'd hear everybody talking about containers and containerization and why we should shift to it. So let us examine what the existing problems are and how containers can help us. Now, existing problems when developing software, there's a cost of virtualization. So we're just coming from a section where we looked at virtual machines in the cloud and infrastructure as a service. And the reality is that, and I'm sure every developer can attest to the fact that when you have an environment and you're trying to develop against that environment, you're going to need virtual machines, right? So the organization might not buy a machine per software that you have. Instead, they're going to go ahead and provision a virtual machine. Every virtual machine needs to have an operating system, which means there are more licenses that are required for each virtual machine, and then any supporting software that you need for your particular application on your virtual machine or set of virtual machines. Those are other licensing costs. So you have to consider the fact that virtualization is not a cheap endeavor at all, especially when it's being done in-house. We also have the challenge of differences in environments, because when we provision a virtual machine and install a particular version of the software or version of the operating system on that particular machine, or virtual machine rather, that environment is set up in a particular way. Then it is very difficult, not very, but significantly difficult to replicate that environment exactly for QA and then by extension prod. And then what we run into as developers is a situation where it works in dev and then there's some slight version difference between dev and QA. So it breaks in QA, and then even when we fix it in QA, it doesn't work out of the box in prod. So there's always going to be slight differences between the different environments, and those can cause, I'm going to say, unnecessary headaches for us as developers and even infrastructure practitioners. Now, another thing is, how easy is it for you to change your operating system? Because when you set up, say, an application for .NET Core, you're going to need IIS, you're going to need certain hosting supporting software based on a Windows server. But then if you need to move over to a Linux server, then you have to consider, okay, you need to use Nginx or Apache or some other hosting software, some other version of this, some other version of that. And it is, it's hard to replicate the running environment in Windows to another operating system. So those are some of the problems that we do face when developing software, especially software that we want to run on any platform. Now, benefits of using containers. One, we have portability. So Docker has created an industry standard for containers so they can be portable anywhere. And I'm going to
talk more about what portability really means. Containers are also lightweight, so they share the underlying machine's operating system kernel, so you don't have to go ahead and provision a new operating system per application. So unlike virtualization, where every virtual machine is its own self-hosted, fully provisioned up machine, so to speak, containers sit on top of one operating system, but then provide a virtual environment where just the software that is needed for the environment can be installed. And then by extension, because of the portability, once we have that template, which we call a container image, we can provision it on top of a Windows OS or a Linux OS or a Mac OS and have the same results every time. There's also the matter of security. Now, once an application is in a container, it's safe because you can always take it, you can lift it, you can shift it, and we can always store our secrets so that we can restrict access to the containers a bit more easily than how we would on a virtual machine. We also look at immutability. So an image, which is the template for a container, will always be the same when it is created. So once again, that feeds back into portability, because if there is a container image for my application and it needs 3 libraries for support, it will always give me that environment no matter where it is provisioned. So I can rest assured that once this is containerized, it will always be the same. If there's a new version, then I would have to create a brand new image with this new version. So at that point, you have an image for version 1 and an image for version 2. So version 1 will never update to version 2. So you don't run the risk of, provisioning the wrong version, because it is clear which version you are going to be provisioning. Now, here's an overview of how Docker looks, and this is taken from Microsoft documentation. So to the left-hand side, you see that we have the operating systems. It could be Linux, it could be Windows, it could be Nginx, it could be Mac OS, whatever it is. Whatever that underlying kernel is, that's to the left. Now, the Docker engine sits on top of that, and it provides us with a server, a client, and a RESTful API. And all of these work together to manage the images that are created. So once again, the image is the template, and using that template and Docker server, we can provision containers, which you'll see to the far right. So the container is the actual instantiation of the template. And then this template can be replayed multiple times. So we can have multiple containers of the same application for different reasons. So once again, the image is just the template. The container is the instantiation of this template. Now, I've mentioned Docker several times. So Docker is a containerization platform that is used to develop, ship, and run containers. Now, Docker does not use a hypervisor. So unlike virtual machines, you don't need a hypervisor. So you can actually install it on your desktop or laptop if you're developing and testing applications. And best of all, it supports all major operating systems. So regardless of the operating system you're using, there's Docker support for it. And it does support production workloads for many variants of Linux and Windows Server versions. Best of all, it is supported by many cloud providers, including Microsoft Azure. Now let's get started with setting up Docker on our machine, and our journey starts off at docker.com. So you can, in your browser, go to docker.com, and from here you can download the appropriate Docker client for your machine. So I'm using a Windows machine, but then you see you can get an Apple chip, Linux, and Intel chip for other types of machines that might not be based on these operating systems. So you can go ahead and install it based on how you need to install it for your particular machine. If you are using the Windows version, it's a straightforward installation using the wizard. And once it has been installed, you will be led to install the Windows Linux subsystem, or Windows subsystem for Linux, rather, that WSL subsystem that we had mentioned prior to this. So it's on the Microsoft documentation. If you just Google Windows WSL, you'll see this documentation come up, and you can follow the instructions. So you can just go ahead and run this using your PowerShell or command prompt as administrator, and it will go ahead and download and install that for you. Now, once you have Docker and the Windows subsystem for Linux installed, then you can launch your Docker desktop. So that may take a while. I already have it installed. You can see I'm even pending an update, but you can hit pause, make sure you have everything set up before you continue. And when you do, then you can launch your Docker desktop. Now, from here, you can look at the containers. If it's the first time that you're running Docker, then you're not going to have any containers in this list. You can also look at images. So from here, you can actually look at local images versus images that are available on the hub. So we did mention Docker Hub in the previous lesson. So what you want to do is in your browser, go over to hub.docker.com and go ahead and create an account. So I'm signed in. I'm going to sign out just to show you what you can expect. And then you can get started today for free. And once you have your account, you can access the different Docker images that are made available for public consumption. Now I signed back in, and here I'm looking at my own registry where I have a patient's database image that I had created. It's available to the public. It's not very useful. I actually created this one for my book on microservices development, where I demonstrated how you can containerize different parts of your microservices application. So you can grab a copy of that book if you want it from the microservices point of view. But the point is, from Docker Hub, I can go and look at different registries. So these are my repositories, but if I click on explore, then I can look at different images, and you'll see that there are several thousands of images available for use. So I can use any one of these, like maybe you need a Redis instance, you need a PostgreSQL instance, and very popular applications have been containerized and are made available to you as container images for you to instantiate containers on your own machine. Now, bringing it back to Docker Desktop, if you go ahead and sign into the hub, now that you have created your account, then from here, you will actually get access to your own repository as needed, right? So here is where I would have packaged my container and I published it to the hub, all using Docker Desktop as the tool, right? And once again, I can look at all of the local images that I would have pulled. And once I create a container, I have access to it afterwards. So you can see here I have a RabbitMQ container, I have a MongoDB container, I have two containers for Microsoft SQL Server, and I have one for Redis Cache. So when we come back, we're going to look at how we can go about bringing in an image and creating our own container.
Now, as it stands, Microsoft SQL Server is almost exclusively only usable on Windows machines. Now, if you're using Mac or Linux, don't worry, there is still a solution for you. Solution number one would be that you can use a virtual machine. So you can use VMware or some other tool that supports virtualization, and you can spin up a virtual machine that has a Windows OS and then use that. Now, that can be resource intensive, and I'm not going to put you through all of that just to use the one software. So the alternative to a virtualized environment for Windows would be to use Docker. I would encourage you to launch your terminal. So once again, I'm using a Windows machine, but your terminal on Linux or Mac OS X would look very similar to this. And you can simply run the command Docker just to make sure that it's installed. And if you see something looking like this, then you know you have access to the Docker CLI commands. All right. So what we want to do at this point is run a command that's called Docker pull. Let me zoom in a bit so it's easier to read. So we're going to do Docker pull. So Docker pull, and then we're going to pull this, what we call image. So Docker has predefined files that outline the environment that is needed for a particular application, and these are called images. So the image that we want is the Microsoft MS SQL Server image. So we're going to do a Docker pull against that image. So you can hit pause, make sure you type it in just the way I have it. And when you press enter, it is going to go ahead say, okay, I'm getting latest, and then you're going to see it downloading. So I already pulled that image, so I already have it on my machine, but you're going to see it say pulling, and then it's going to start showing you metrics of it downloading, and it would actually look something more like this. So this is a screenshot I took earlier from when I was downloading it, and you're going to see that it's going to spawn up a bunch of lines looking similar to this, and you're going to have these downloading tags. So once that is completed, the next step is to actually run it. So to run it, you need this command. So we're going to say docker run, and then -e, and then we'll do the EULA accept. So what happens is that SQL Server usually has one of those documents that you need to accept the terms and conditions to. So we're just putting it in a parameter that yes, we accept the terms and conditions. And then another one that says SA password. So if you looked at the installation process when we're using Windows, we can use Windows authentication to connect to the database, right? So all we need is a machine name, and we can use the Windows user, the current Windows user, Windows authentication, and just connect. Now, because this is Docker and it's a container, there's no Windows or there's no Mac or there's no Linux authentication. So it's not really that you can just connect using the default user on your computer. So this step is applicable whether you're using Windows, Mac, Linux, etc. So what we need to do is specify an SA password. So SA is the default user, which means system admin or system administrator. Every time you install a database engine for Microsoft SQL Server, you get this SA user. So we're going to set up this SA password, and you can put in any password you wish, right? I'm just putting in a strong password here. And this is really a password that you might see in other demos that you might watch anywhere on the internet. So this password is not necessarily unique to me or to this exercise. You can put in any password value that you feel comfortable with and you know you will remember. So I'm just putting the word strong password, of course, with special characters, numerals, and a couple capital letters. Then we specify the port. So the port here at the front is the port that we want to go through, and the port on the other end of the colon is the port that it will map to. So what this means is SQL Server by default broadcasts from port 1433. That's the default port. So without doing anything, specifying any port or anything, we'll always go through 1433 once we're connecting. However, Docker is running in its own specialized environment. So we need to map. So this is the default port, and then this is the port from our machine that we want to tunnel through to get to this port. So you could actually just leave that as 1433, 1433. So if you don't have SQL Server installed already and you're running Mac and Linux, then 1433, 1433 is fine. You don't have to do anything extra. You can just connect. However, because I'm using a Windows machine, I had to change my port because 1433 is already occupied by my native SQL Server installation. So I'm just showing you that you can do 1433, 1433 by default, or you can put in your own specific port if you so desire. Then the next and final thing is we say -d, and then we specify the image that we want to run. So basically we're saying, Docker, run this image and make sure that all of these parameters in between are configured. That's essentially what we just did. So when you press enter and you allow this one to run, what it will do is launch that image inside of the Docker UI. And in the UI, you're going to see that you now have under the containers tab a container, and you could have given the container a name. We didn't specify a name in the command, but you could have put -n and given it a specific name. So when you fail to provide a name, you'll get a random name like what you see here with these names. At least Docker UI will indicate the kind of image that we're using, and you will see over here the port specifications according to what we had configured. So like I said, you can do alternative ports, and this would be good if you have several containers of the same technology that would block a particular port running. But if you don't have the technology installed, like with my MongoDB, I don't have MongoDB running on my machine.
So I'm not going to use an alternative port. I'm just going to say use the default port, map it to the default port, and act like the actual software. For SQL Server, I do have several instances running, and I want this instance to have a specific port so that I can tunnel directly to it when I need to connect. Now let us look at connecting. So to connect, I can use any of my SQL Server management tools. We've already looked at some of these tools. Just to make this quick, I'm going to use the Data Studio. And to connect, I'm going to go ahead and create a new connection. And for a server, I'm going to write localhost. Now the Docker is going to run at localhost, and that's why that port number is important, because typically localhost, 1433 would be the way to connect to the locally installed SQL Server instance, if especially if you're running professional or enterprise or developer tier, right? So localhost with the port would connect me to the default installed instance on my machine. However, because I want the Docker instance, I have to go to localhost and the specific port that I had given it during the container setup. For authentication, I can't use Windows authentication like we established. I have to use SQL authentication, and I'm going to say SA, and then the password, which I forgot. So here's a quick way that if you forget these environment values, you can retrieve them from the Docker UI. You can just click on the running container, and you can use visual cues to know when it's running. So here it's running, and you'll see logs happening in the background. You can go to inspect, you can go to terminal, etc. So if I go to inspect, I'm going to see all of the environment variables that were configured. So we did the EULA, accept EULA. Why? That's an environment variable. Here's the SA password, and look at that. I have the password value available to me right here. So anytime you do these setups and you set environment variables and you might forget, we're all human, you can always just jump over to the running container, go to inspect, and see the environment variables. So I'm going to jump back over here and place the password, and then I'm going to click connect. Now I'm getting this error that it was successful, but it needs a trusted connection. Okay, so I'll just enable trust server certificate, and there I am. I am now connected to the SQL Server instance running in my container. And this is a container that I actually used in another course, ASP.NET Core Cross-Platform Development, which is a course where I actually teach on how you can use ASP.NET Core to develop a solution in any environment, right? So we do a little Dockerization in that course, and I'm just showing you that. I'm just sharing that with you to let you know that that's why this database exists. So you obviously would have no databases if you just created this container. Now, this container works like any other SQL Server instance, and as long as the container is running, then you can interact with it just the same. You can connect to it. You can build apps to use it. And guess what? If I stop it, so I can stop this container at this point, right? If I try to do anything else here, like try to go into the database, notice that my data studio is going to hitch. It's hitching because it has lost connectivity with the database, all right, with the server. So as long as that container is running, so that's why we said that, when you install software, you might not necessarily want it to be pervasive and running all the time. You want to stop it and start it on demand. That is where containerization can play a big part in helping you to be as efficient with your system resources during development as possible. Now that we have some experience pulling an image, setting up a container, and these steps are well documented, so I'm not making this stuff up. You can find all of this. Once you find the image you're interested in on Docker Hub, you can click it and see all of the recommended ways that you can set it up and all of the environment variables that are needed for the configuration. But now that we have seen how we can use a third-party image, let us now set up our own .NET Core application. Look at one, how we can connect to this image, and two, look at how we can containerize our own application. Now let's create our own ASP.NET Core project, and in the future we're going to containerize it, right? So of course, we're using our regular solution. I'm going to add a new project, and this time I'm going to go with an API project. And I'm only choosing an API in keeping with theme that containers and containerization plays well with microservices architectural design. So I'm going to jump over here, create our new API project. I'm just going to call it microservice 1 api.containers.demo. So you can reuse the name, of course, you don't have to. And then I'm going to hit next. Now, in this step, we get to choose our authentication type or framework, and we can choose to enable Docker. So I'm not going to enable Docker here. We're going to add that manually or use a different method of adding it. But for the second microservice, we'll see the difference when we do that. And because we want to keep it simple, I'm just going to do a minimal API, and then we can hit create. Now, of course, if you're using Visual Studio Code and the .NET CLI, you open your terminal and you're going to type in the command .NET new web -o for the output and give that project its name. And then once that's done, you can cd into that newly created folder and do code full stop to launch Visual Studio Code in that folder. So now that we have our standard web API project, and we're all developers, so we know what to do now. We start writing our beautiful code and we connect to our database and all of those assets. The thing, however, is once again, when we have to move from our machine to the dev environment and we deploy, there might be differences between the environments that make it work on your machine and then it doesn't work on dev. And then we end up with excuses like it worked yesterday, or we say, well, it worked on my machine. No one is going to use your machine in production. We all know this. So that is why containerization makes our application far more portable and far more stable regardless of where it is deployed. Now, I'm going to add container support to this application. So I created the application and let's say this, we wrote all of the beautiful code and everything, but now we need it in a container. So I'm going to right click on the project and then I'm going to go down to add, and then you'll see here Docker support. So when I click Docker support, it's going to ask me, okay, what is the target OS? I'm going to leave it as Linux, but obviously you could change between, and you do want to make sure that you choose an appropriate environment based on your dependencies and your library choices, because not everything works on Linux. So, but for now, for this simple app and .NET Core is cross-platform, I'm going to use Linux. So I click OK, and then we get this new file called a Dockerfile. So this Dockerfile wasn't there initially, but let us just assess what this Dockerfile is doing. And it does look confusing, but when you read it through, you'll see that, okay, it is something that can be understood. The first thing it does is pull a base image. So from, and then it's saying the image name. So remember when we did our Docker pull for SQL Server, we had to specify a path similar to this, where we said SQL Server instead. We did not specify a tag. So if you want a specific version of an image, meaning this is the image, but then colon, and then the value after the colon means the tag or the specific version that you're interested in. So we're doing an ASP.NET 7 application. So obviously we would want the base image to be a .NET 7 ASP.NET image. And then we're saying as base. Then it's going to specify, okay, once you're creating that container, create a work directory named app, expose ports 80 and 443. And then from this SDK image, we want to do a build. So once again, specify the work directory to be src, and then copy the files from the csproj directory, right? So you see here, these are just the paths. So copy this csproj file from this path pretty much, and then do a .NET restore command. So here you start seeing that it's just using the same .NET CLI commands that we use. It's just doing it on our behalf, right? So it's doing a restore against that csproj file, and then it's going to copy everything in that file, and then it's setting up that work directory to be once again there. So if I go through it line by line, sure, it makes sense, right? Essentially, we're going to run again the .NET build as release, and the output is going to be app/build. So these are directories that we don't have to create, and they're not being created on our machine. Instead, they're going to be created in the container that is doing this compilation, right? And then it's going to say from this step, right? After this step is completed, take whatever it is, call it publish, and then we're going to run the publish command, which is going to do the same kind of release, take what is in that publish folder, and it's going to give it a little flag here to say use app host equals false, right? Once again, this is generated for us. We don't necessarily have to author this file. It's good to understand it to modify it, but generally speaking, you don't have to. And then after all of that, from base, it's going to say the work directory is app, and then it's going to copy everything from publish to that directory. And then the entry point is going to be that DLL. So .NET Core apps usually run based on that DLL. And that is what starts up the application running in the container. Now, how do I know that this is going to run in a container? So let me switch over to the startup project of the microservice that we just created, and you'll see that the start button is now saying Docker. So with all the other ones, like if I go to the Blazor, it said HTTPS, right? And we already looked at the launch settings, and we know that the launch profile has the HTTP, HTTPS. But if you look at this, you'll see that now there's a Docker entry here, and the Docker entry is going to have that launch URL with the Swagger. So everything gets configured for you once you added the Dockerfile, but basically it's going to go ahead and launch Docker, right? So when I go over to this new startup project and say run with Docker, my application will launch just like I expected it to, right? So it will launch in the browser, and I'll be able to go ahead and use it like I expect to. What evidence do I have now that it is running in a container and not just being run by Visual Studio? Well, if you look at the Visual Studio window, this new panel would have appeared. So you probably have never seen that panel before, containers. And in this panel, you see that this container, or the application that is hosted or being run, is here as a container that is being run right now. You'll also be able to look at all of the environment variables. So you'll see the version, development, all of those environment variables that we didn't set, but they're all there, right? We also have ports. So you look at the port here, you'll see that it is creating a port. So remember that we had to create a port to tunnel to 1433 when we were doing our SQL Server image. So you'll see here that we have a port that is mapping to port 80 and a port mapping to port 443. And either one I can click and browse to. So when we look at the address in our Swagger UI, we'll see that we're on the 769, which is mapping to port 443. You'll also notice, if you have Docker UI open and running, that you have a new container with the name of the application also running, and it is showing you the port, and you can click to show all ports. So these are all visual cues and evidence that we have now containerized our application, and this is a microservice. And once again, it's not limited to microservices, but it is recommended with microservices because it allows each microservice to live in its own environment, independent of all the other services, with its own dependencies and everything that it needs to run effectively. And once again, it is portable. Now, if you're using Visual Studio Code and you want to containerize the application that you have here, what you'll need to do is go and get the extensions for Docker. So if you just go over to extensions and you can just search for Docker. I have it installed. I was trying to scroll and find it, but you can just search for Docker and go ahead and install the Docker extension. Make sure that you're getting the Microsoft one. And then once you have that, you'll get this tab that allows you to see all of the containers, and it gives you a similar, well, I don't want to say similar, but it gives you enough information compared to what you would have experienced in Visual Studio about the running containers, as well as different images that you have available to you if you have pulled down several images. So let us containerize this particular app that we provisioned in our Visual Studio Code. Now in Visual Studio Code, hold down Ctrl, Shift, and P, and you'll see it right here, show all commands. So Ctrl, Shift, and P, and that will launch our command palette. And then you'll see here that we have the option to add a Docker file. Now, if you don't see that option, you can just start typing Docker and it will appear regardless. So recall that adding Docker support is really just about adding a Docker file. So if we select that, and then I can specify the type of application that I want to support. So it's an ASP.NET Core application. And then we can specify the OS once again and specify the ports. I'll leave that port. That's fine by me. I can choose if I want a Docker Compose file. We're going to look at Docker Compose later. So I'm going to say no for now. And then it is going to go ahead and generate that Docker file for me using a very similar syntax to what we saw just now in Visual Studio. Now, to run this API in Docker from Visual Studio Code, we can go over to the debug tab, and then I can choose from the drop-down list the docker.net launch, and then go ahead and run. Then you can see some activity going on down here in the terminal. And if you look closely, you'll see that the logs are very similar to what you might have seen in Visual Studio when it was running, but it's running some Docker commands in the background. And then after some amount of time, we're now going to get our Docker app running, and we see hello world. It was a simple API endpoint that would just return hello world. If we look in our Docker UI, you'll see the new container running as well with the name. All right, so here we have the port 32771 running against port 5099. So we could have actually specified that we wanted 80 and 443 for this app. I could have said 80, 443 when it asked me about the port. I didn't do that, but I'm just letting you know that that was an option. And that would have given a similar mapping as we have here. So now you know how to containerize your .NET Core application using both Visual Studio and Visual Studio Code. Of course, we're still running in debug, so I'm going to stop the debugging, and that allows us to actually debug our apps while they're in a container. Now, if I just go through the steps again to add a new, let me add a new project, sorry. When we're adding the project, we had the option to add Docker support. So I'm just going to click on a random one here, and we had the option to enable Docker. So all this would have done was allow us to choose the OS here, and then it would have generated our project with the Docker file already provisioned. So you can do it from the get-go if you know you're going to use Docker, or you can easily add it afterwards when your ambitions reach to that point. Now with .NET 7, there are .NET commands that we can use to actually publish our app into a container without the need for a Docker file. So a Docker file can be used for any version of .NET, and it is universal. You don't have to worry if you're using a Docker file. But when we come back, we're going to look at how we can use native .NET commands to containerize our app. Now in this lesson, we're going to look at how we can containerize a .NET app using .NET Publish or the native .NET CLI commands. Now this is unique, at least right now at the time of recording, to .NET 7, and I'm sure it will be available in later versions. So for .NET 6 and below, you still need the Docker file. However, if we're pressing ahead with .NET 7, then we can do this. So I'm just going to go ahead and create a new project, and I'm just going to use Visual Studio for this demo, but you can feel free to follow along using Visual Studio Code. Most of it is going to be command line driven, but I'm going to create another microservice API. So I'm going to call this microservice 2 API.containers.demo, and let's go ahead and create that. I'm not adding Docker support. I'm not changing anything about the previous setup, and now we have our new project. So to this new project, we need to add a new package, right? So we're going to use the .NET CLI command. I'm using .NET CLI because, you know, everybody can use it, whether you're in Visual Studio or Visual Studio Code. So I'll just launch the terminal here in Visual Studio, and I'm going to run the command .NET add package, and we're adding Microsoft.NET.build.containers. So go ahead and install that package. Now with that package installed, we can verify by just clicking on the CS proj file, and we'll see it here. Now, when we want to give our container a name. There are times when we might have invalid names as projects. So if you wanted to change the name, you could actually add a node here in the property group section of the CS proj, and this would be container, let me get my spelling right, image name. And then with this node, you can actually give it another name. So I'm going to call it, let's say microservice dash 2, right? Just something, it's microservice dot 2.api.containers.demo. So I want this container to just be called microservice dash 2, right? Just to show you that we can rename the actual image before it is published. Now, when I'm ready to publish using the .NET CLI once again, I can say .NET publish, and I am going to specify the operating system, so --OS, and I'm just going to stick to Linux, and --arc, and we're specifying 64 to show that we want a 64-bit. Then we say /t publish container, and then /c release. So with all of those, what we're doing here, we're saying that we want the release configuration, that's the -c. Once again, the -art is specifying a 64-bit architecture, and we are specifying that we want an OS, a Linux-based OS. Now, when that command is run, you're going to see a printout of a few logs, but go ahead, run it, hit pause, and when it's done, we can assess together. But most importantly, you're going to see that it built the image with the specified container name. Now, if we didn't specify that container name node, then you would have gotten an image similar to the project name, which we've seen before. So those are just little nuggets that you can bear in mind. And the fact is that whenever we need to configure this image, similar to how we have the Dockerfile setting up all sorts of environment defaults and so on for the container, we can actually specify different nodes here. So if I wanted, let's say we're using .NET 6, not .NET 7, or I just wanted a .NET 6 runtime base image, I could actually come here and specify container base image and then put in the name of the image. So let's say if I wanted the runtime for .NET 6, I could say mcr.microsoft.com.net/runtime and then the tag for 6.0. All right. If I wanted something else, like if I wanted to actually tag this image myself, then I could specify, and I'm just going to remove this one, it was an example, but I could specify container image tag, and then this would allow me to set my own version of this particular container image that I am pushing. So let's say after a bug fix, the original image was 1.0.0, but maybe I did a bug fix and now I want this to be 1.0.1. And then if I rerun the command, then we're going to see that we get a brand new image with that tag version. And there we go. So I just reran the command and now I have the new image with the tag 1.0.1. Now, do remember to save the CS proj file, and this is why I have so many runs. It happened to me the first time I didn't save it. Whenever you make a change here, you have to save, because this is not a build operation, it's a publish operation. So if you don't save, then it won't see the changes to be able to go ahead and push. So there are several other things that you can actually add when you are configuring your app image from this point. So if you want to have multiple tags, you can actually say container image tags. Notice the S, different from tag. And you can specify different version names using alphanumeric and semantic versioning techniques. And you would just want to use a semicolon to separate each version tag. You can also add an item group where you can add more metadata. So you can configure a container port that you want this container to have once the image is created. You can also create a container environment variable. And we've seen this before, especially when we were setting up our SQL Server container where we had to accept the license agreement. So we just go ahead and create this variable. So every time the container spins up, that variable value is available. So here we're setting the logger verbosity to be trace. This means that this container is supposed to spit out as much information as is generated by our .NET Core app, right? And we know that .NET Core apps can be a bit chatty, so it should be spitting out all of that to the container console. Another example of an environment variable that you may want to set would be one for ASP.NET Core environment. So here, when we're running it locally, it's going to come off with development as an environment variable. However, when we do a publish and we're doing configuration release, that variable is going to be production. So we could actually override that default setting and say, when you're in this container, I want that environment variable to be development or QA/staging or production, etc. So that's how you can think of the use of environment variables. You can also add labels, and labels just help with the metadata and the listing when it's in the registry. We can also specify the registry here, but we're not quite ready for that yet. So with all of that done, I can do another push and create that image or update that image. So these, once again, are images, not containers. So now I want to actually run my image. Now, to make sure that the image exists, I can jump over to the Docker UI, go down to images, and then you'll see here that you have all the versions of the images that you would have published should be here. So you see here that I have 1.0.0 and 1.0.1. And if I select either one, you're going to see this section called layers, where it outlines the different steps that should be followed to finally build the container for this application. If I go over to images, you'll see that it is using the Debian image because I said I wanted Linux, and it's using my image that I had created. So to run this, we could actually click on the image and then click run. Actually, I don't like to do that, right? I actually prefer to use the command line. Now, beside run, you'll see pull and push to hub. So this is our local image, so there's nothing to pull. But if we do a pull, it means we would get the updated version of this image, especially if it's supposed to be the latest, right? So as we've seen, we have been able to update the image with the same tag. So if there are updates on that version, we can always do a pull and it will do an update. We can also push to hub, which means that this is where we're going to push from our local repository to Docker Hub. And I would have shown you already how that looks. At least when you have your account and you do push to hub, you can see your own container up in the hub, and you can pull it back down on any other machine as needed and start working. So that's how easy it is to memorialize your container when you have created it. Anyhow, let us go ahead and run this new container. So what I'm going to do is launch a terminal window, and I'm making this one bigger. So I apologize if using the one in Visual Studio hurts your eyes, but I hope to correct that now. So I'm using a terminal window. I've already gone over to the directory where our microservice 2 API demo sits. And what I'm going to do here is run a command that says docker run. So we've seen this docker run command before, right? And I'm going to specify -it and specify a port. So I'm going to tell this that I want it to run on port 8080, and that should tunnel through to port 80 for regular traffic. I won't complicate anything and use 443. And then I'm going to specify the name of the image. So microservice -2, and I can specify the tag if I want or not. So let me just go ahead and hit enter. Let's see what happens. So you see, unable to find image with the tag latest. So it's very important that you go ahead and set that latest tag on whatever should be pulled by default. So let me go ahead and specify that tag, which is 1.0.1, and then try that again. And this time it's actually going to spit out some logs that look like ASP.NET Core application logs. So what happens if I try to reach the application? So we did say that the application should be live at port 8080. So then I bring up a browser and go to localhost port 8080, and then I put in weather forecast, which is the endpoint that lives at that API, we see that we're getting back our API, right? And we'll see as well that we have a little message coming up about the HTTPS redirection. That's fine for now. If we look in the Docker UI, we'll see that we have a new container running as well. And this one is, I don't know what that name is, but once again, we could have specified the name in the Docker run if we wanted to. Now, if I click on this, you'll see that it's also spitting out logs around here. So you can watch the logs from the console, you can watch the logs from here. And actually, the reason it's spitting out to the console that started it, let me just stop that and redo that run command. The reason it's taking over the console is because we didn't specify -d, which means that we want it to run as a daemon, run in the background, right? So here it frees up the console, right? So that's another little tidbit that you can use to free up the console when you want to run your Docker container, but you don't want it to take over the console. So here the Docker container is running once again. I just had to hop out and hop back in, and you see it's running once again, and we can view the console from here without taking over our local console. So now you see how you can containerize your .NET Core application using your .NET CLI commands and certain configurations. Read up on the documentation. You can play around and you put in different configurations that resonate with you, but I'll leave that up to you. Now, when we come back, we're going to look at how we can use Docker Compose to handle the orchestration of multiple apps that are containerized. So we already have an idea of what container orchestration is. Container orchestration basically means that we have several containers and we need to be able to orchestrate how they start, why they start, if one depends on the other, which one starts first, etc. So there are several things that we need to set up for our containers before the work actually begins. So if I have, say, a microservices application and all of these microservices exist in their own containers, but for the application to run, all of these apps need to be up and running simultaneously, then we would want to make sure that we have a very repeatable way of having all of them run at the same time. So that is where Docker Compose comes in. So I'm just going to go ahead and add Docker support to our second API, and just by right-clicking it, doing following the wizard. Of course, you know to do that in Visual Studio Code as well. But now we have Dockerfile existing in both of these apps. Now, when I right-click again, I can actually add container orchestration support. So when I click that one, it's going to ask me, okay, what orchestrator do I want to use? And by default, I'll have Docker Compose there. So I'm just going to go ahead and click OK. Confirm that I want to use the Linux OS. And this is going to generate a new project with some new files. So the first file here is a Docker ignore. So similar to our git ignore file, there are certain things that we don't necessarily need to bring over with the container and everything. So it's just saying ignore all of those and compile everything else. We also have the launch settings.json, which gives us a Docker Compose launch setting. And you see here, now it's taking over. We can just say Docker Compose and run that one time here in Visual Studio. So with that, we can just spin up whatever the Docker Compose file says. So now our Docker Compose file has two parts to it. We have the Docker-compose and we have the override. Now our override allows us to specify certain settings that we want on each container. So here, let me go from the main file first. Here I'm saying that the version was set. I'm not going to change that. And then we have a section for services. And then under services, we have our first service, which is the microservice 1 that we had specified we wanted to add orchestration support for. So it's going to say, well, when I build out this container, I'm going to call the image, whatever that generated name is, hyphen that name. And then I'm going to build using the context, wherever the project is, and the Docker file or the set of instructions on how this container should be generated exists in the Docker file in our project. So for as many applications as you have that you need to spin up at once when you are developing, you can add orchestration support. So I can also add orchestration support to the second microservice and to the third and to the nth. So if I go ahead and do that again and specify the same settings, then you're going to see that I now have a second microservice here in that file. Nice and easy. So if I jump over to the Docker Compose override file, and it grew because now we have overrides for two different services, and as many services as you may have overrides or not. But here what we're doing is specifying that the environment should be development. We can always change that based on our needs. So while we're in Visual Studio, of course, that environment variable will definitely want to be in development. We can specify that we want HTTPS and HTTP ports. There we go. And then we can specify volumes. So a volume in Docker or in containerization basically is an area for storage, for persistence. So when the container is running, we don't want to lose the data. And when we start up the container, it should remember the last place it was. So this is especially important for like database containers and Redis cache containers, etc. So when we say volumes here, we're just saying that we want to store the user secrets. We also want to store certain other configurations, right? So whatever those configurations are, please persist them even when the container is not running. So now that we have a quick tour of what our containerization or Docker Compose really looks like, or Docker Compose and override files, let's go ahead and see what happens when we run with Docker Compose. So I'm just going to hit run. And in our browser, we have our first microservice running. Now, the first microservice was created with Swagger support, and we see how we can get to that endpoint. But if I go back over to Visual Studio, you'll notice in the section with the containers, you'll see that I have the microservice 1 container. So I have an existing one for it. So it's creating a brand new container based on the Docker Compose, and it is creating a container for the second microservice. And just by clicking this one time, it was able to launch both of these services that may or may not depend on each other. If I look in the Docker UI, you'll see that you have a new Docker Compose section appearing, and this Docker Compose section has both containers for the microservices. It also has the different ports for each one. So I can easily go ahead and browse to either one, and I can just stop all of them using one stop. I also could have and probably should have stopped it from Visual Studio as well. So now that we understand how Docker Compose and orchestration works, and there's another level to this where we would introduce Kubernetes, which does much more than just spin up containers, but we'll look at that briefly later on. In the next lesson, we're going to jump over to Microsoft Azure and we're going to create our container registry service and then look at how we can push our containers to that registry.